Thank you very much. So yeah, my name's Alex. For those of you who don't know me, I'm a researcher at nChain, been working there for about a year. And today I'm going to talk to you about an idea that was actually, the original idea came from Andy and Steve last year, and we spent a bit of time writing the white paper, and we actually have a proof of concept. Unfortunately not ready to show today, but we do have one. You've got to believe me on that one. But yeah, so I guess I get started. So talk's going to be motivation. Why do we need miner ID? Why do we need to enable users to be able to identify and transact with miners? A bit about the concept itself. So something called the Cornbased document, which is an implementation detail, and then some of the potential applications. So context. As we scale the Bitcoin SV blockchain and blocks get bigger, there's going to be a shift. Hopefully there's going to be a shift in the kind of ratio of fees that miners incur, from block rewards to transaction fees. So sometime in the future, of course, the block subsidy will run out, and miners will have to support themselves entirely on transaction fees. However, that's not, I mean, miners are, let's say, the gatekeepers to quite valuable blockchain data, right? So we need to be able to develop the tools so that they can harness that data and access additional streams of revenue based on that data. Yeah, so a bit about how what miners do at the moment. So let's say I want to pay Jack over there with my Handcash app. I generate a transaction. I broadcast it to the miners that I'm connected to, or nodes that I'm connected to. They'll validate the transactions. And then if the transactions are valid, as in they apply by the rules, then they'll flood the network with those transactions. And then the recipient of those funds will be able to see that, one, the transactions have been accepted by the miners, and of course, if they want to wait for it to be included in the blockchain, then they can wait for that confirmation. However, I'm sure that many of you have heard about zero conf. So at the moment, it's kind of, there's a perception that transactions before they've been included in the block are not secure, because there's not a 100% guarantee, or there's not a high degree of certainty that the transaction will not be double spent. Miners are in a position to ensure people against zero conf, or at least they should be able to. And in addition to that, you have services like Twitch, like WeatherSV, that are processing a lot of data transactions, and they should be able to also provide chain analysis, providing services related to that data for users. However, the problem here is that at the moment, there's no real way of establishing who a miner is. So users will need to securely identify, they'll need to be able to identify miners in order to interact with them. So I'm not sure if you can see this, but the way in which miners advertise themselves at the moment is using something called Coinbase data, or Coinbase tag. So whenever they mine a block, there's a small amount of data in the first transaction that they can, they can alter and add in maybe a kind of serialized ASCII of their web page. So if you go on a block explorer, you often see some kind of tag like mempool, CoinGeek, and that's essentially the only way we have at the moment for miners to identify themselves. And it's useful only really for block explorers at the moment. So block explorers use it in order to show you the lovely pie charts about hash rate distribution. But the problem is that this information, again, if you go on any block explorer, the information in the Coinbase text isn't standardized across the network. The information isn't secured using public key cryptography, so it can be altered, and it derives no real financial benefit. Also, there's the problem of impersonation attacks because there is no real incentive to ensure that data. You can have, for example, not that this does happen, but you can have an unknown miner come on and pretend to be someone else for whatever reason. So, the miner ID is the actual invention itself is a protocol for enabling miners to accurately represent themselves on the network. So if I get to the kind of main piece of it, the main invention is something called the Coinbased document, which is a serialized JSON file that the miner embeds in a transaction. So along with a public key, real-world identity data, there are also some tools for managing ID data that a user's wallet can be configured to interact with. And the Coinbase document itself is stored within an unspendable output in the Coinbase transaction. Crucial to this invention is something called a validity check transaction. So I mentioned before the whole problem about miner spoofing, as in a miner coming on and pretending to be someone that they're not. In the invention, we use something called a validity check transaction as a tool that the wallet can independently verify the content of the Coinbase document. So again, the Coinbase document is stored in the Coinbase transaction. Miners add it to their candidate blocks, and when they mine a block, that's how it gets stored in the blockchain. And then from that, you can independently kind of view a blockchain. As you see here, it's kind of colored by the different mining pools. And it's secured through both public key cryptography and proof of work. So the applications, there are many. Since with the Coinbase document, you can find a public key in which to identify a miner. You can do something called a handshake, which I'll demonstrate, I'll show you through in a second. And this can enable you to establish kind of payment channels, a kind of financial connection, peer-to-peer encrypted communication, and it also serves as a way to establish a reputation for the miners. So the first application is what's called a wallet handshake. So let's say Alice here has seen that a miner is advertising a zero-conf guarantee. Now, if the miner says, okay, well, this is my public key, her wallet can be configured to download all of the Coinbase documents, can verify, can check validity, can send a message to the miner, and the miner can sign that message, and the public key used to validate the signature has to match the public key in the Coinbase document. So that's one application. I think the main application, though, is going to be miner to miner. So Steve mentioned earlier that we were developing an algorithm for block streaming. I know it's quite sensitive, so I won't go into too much detail, but the block streaming protocol is going to be one of the main things that's going to enable Bitcoin SV to scale, transaction volume, block finalization times. In order for it to work, there needs to be at least a minimal level of trust established between miners, and the Coinbase document is part of that. So, quick talk, but thanks for listening.
Thank you so much.